Chapter 1: The 6G Vision. As we transition to the 6G era, the boundaries between the physical and digital realms are dissolving. As we transition to the 6G era, the boundaries between the physical and digital realms are dissolving. We are moving toward the intelligent connectivity of everything. Where every entity has a dynamic virtual counterpart. This requires a fundamental rethink of wireless architecture, moving beyond traditional 5G speeds toward immersive communication. We explore holographic teleportation, the tactile internet, and the birth of the global mirror world. 6G is designed to connect intelligence itself, creating a seamless mirror world that is synchronized in real time. This vision is not just an incremental step, it's a revolutionary leap into a world where connectivity is ubiquitous. We are building the infrastructure for the Metaverse and Industry 5.0, where digital twins are replicas of our physical world. This requires us to rethink the entire stack, moving from ad hoc AI augmentation to true AI native reasoning. We'll explore the 6 major scenarios defined for 6G, including immersive communication and hyper-reliable networks. The goal is to reach a data rate of at least 2.0 terabits per second, catering to holographic teleportation. This is the foundation of the 6G era, where data doesn't just flow, it understands. We are designing a living, sustainable network that can grow with its cumulative knowledge, executing operations that cannot simply be done when being overly reliant on existing data. This evolution transforms our world into a fully synchronized physical-digital space. The 6G network is not just about speed, it is about the intelligence required to manage massive data influx. We are shifting from a paradigm of simple bit pipes to one of knowledge-driven interaction. Every node in the network will possess reasoning faculties, identifying structure, and deducing connections in real time. This is the foundation of 6G, moving beyond ad hoc augmentation toward AI-native wireless systems. Chapter 2: The Shannon Trap. 5G was built for data, but 6G must handle city-scale digital twins. Our current bit pipe models are reaching their breaking point as the volume of bits becomes unmanageable. We are drowning in data, but starving for knowledge. Sensors generate a continuous stream overwhelming our spectrum. We are hitting the theoretical limits of physics, what engineers call the Shannon Trap. Shannon information theory, defining symbol accuracy, is reaching its ceiling. Repetitive transmissions waste resources. In the standard setting, the transmitter does not attempt to automate message generation at the receiver. This passive behavior and asymmetry makes systems susceptible to adverse channel conditions. We need a major leap from traditional bit reproduction toward a reasoning plane where data becomes semantic substance. We must break free from the bits. The data tsunami is not just a bandwidth problem, it's a structural challenge. We must address the interoperability of heterogeneous devices using different protocols and incompatible formats. Current AI-based approaches remain limited, failing to leverage knowledge accumulated through operation. They rely on discrete elements to fine-tune operation, remaining tied closely to the raw bits. 6G must exploit causality and stochasticity to identify structure, deduce connections, and extract semantic noise. This is the only way to build a living, sustainable network. We move from reconstruction to a reasoning problem. If the receiver is endowed with the ability to generate its own messages, the network becomes more robust. This sense of symmetry improves robustness with respect to channel and network irregularities. We must reduce reliance on brittle spectral resources and rely on computational resources to yield semantic content. The goal is to acquire more knowledge with less data, achieving high rate, low latency, and high reliability. This is the challenge of the 6G era. We need a paradigm shift. We must break free from the trap. Chapter 3: The Shannon Trap. We are hitting the theoretical limits of physics. Transmitting every single bit for real-time virtualization is becoming mathematically impossible. Shannon's information theory, which defined the first-level technical problem of symbols, is reaching its ceiling. In 6G, the semantic problem, conveying meaning, can no longer be ignored. We'll explore the Shannon Trap, where the cost of increasing bit rates begins to outweigh the system complexity. To break free, we must look beyond symbols to the essence of communication. Since its inception, the digital communication system problem, as posed by Shannon, has been a reconstruction problem. The fundamental goal was the capability of reproducing at one point a message transmitted from another point. But 6G pivots. We are moving from a reconstruction problem to a reasoning problem. We can bypass the spectral efficiency limits that have governed digital communications for decades. By exploiting accumulated knowledge, the network can reduce reliance on brittle spectral resources. We rely on computational resources to yield semantic content rather than reconstruct raw data. This is how we escape the trap. We are moving from uncertainty to exploiting historical message patterns. If the structure within historical transmissions is learned, the receiver can generate that structure. The receiver can generate that structure rather than continuously reconstructing it bit by bit. This is the leap from Shannon to semantics. We move from mere data to semantic substance. Chapter 4. The shift to semantic communication. Instead of transmitting raw bits, 6G pivots to transmitting meaning. We explore how semantic communication identifies the core structure of information, reducing bandwidth significantly. It's about doing more with less, much less. We transform the bit pipeline into a knowledge exchange. By attributing meaning and context via representations, we transform the latent bit pipeline. This shift enables the transmitter to understand and transmit information represented by semantic symbols. This allows the receiver to access the meaning. The apprentice must generate content from representations. In contrast to a passive receiver, an apprentice must be able to generate content from a representation. This is not mere data compression. We are identifying patterns that map to structure and content. While compression identifies statistical redundancy, semantic communication identifies patterns that map to content. Semantic communication leverages reasoning faculties to identify the underlying structure of the message. This is particularly beneficial for scenarios where link reliability is intermittent, like in non-terrestrial networks. By exploiting history and context, we can achieve more with less. This is the foundation of 6G's AI nativeness. We move from transmission before understanding to understanding before transmission. We are building a system that can proactively make decisions and draw conclusions based on logical intent. This transformation humanizes communication, mimicking knowledge-driven conversations. We rethink the problem across Weaver's 3 levels, moving beyond technical symbol accuracy. We must move toward reasoning-driven AI-native networks that perform versatile logic and generalizable intelligence. This holistic vision is the key to 6G success and the foundation of synchronization. By identifying every semantic content element and crafting its representation, we avoid random information complexity. This is the cornerstone of the semantic revolution. We are moving towards a semantic language. This allows a transmitter and receiver to communicate at a semantic level. This shift ensures the E2E network becomes less reliant on the wireless channel. This is the foundation of 6G. Chapter 5. The Hierarchy of Information. We break down the communication problem into Weaver's 3 levels. Level A concerns technical symbol accuracy. Level B concerns the precision of the desired meaning. Level C concerns the effectiveness of the received meaning on the conduct of the system. In 6G, we move beyond symbols. Semantic representations must satisfy 3 key properties: minimalism, generalizability, and efficiency. Information is no longer just uncertainty, it is semantic substance. A data stream is rich if it improves reasoning. Chapter 6. Reasoning-driven networks. 6G is AI native, move from training-dependent decisions to proactive reasoning. Radio nodes become self-governed and self-optimized, maintaining synchronization even in harsh environments. Reasoning systems can operate with less input data because they understand the underlying structure. Chapter 7. Causal Reasoning and the Ladder of Causality. We examine associations, interventions, and counterfactuals. The do operator allows the machine to simulate changes and predict outcomes without transmitting new raw data. By understanding root causes, machines build a shared language that is invariant to distribution shifts. Chapter 8. The IESC Architecture. We deconstruct the wireless stack into 3 semantic-empowered layers. The reasoning plane handles real-time inference, feeding the control plane with information for interventions. Optimization in 6G is governed by a chase behind computing resources. Distributed computing ensures fairness. Chapter 9. Semantic-based KPIs. Performance is no longer measured solely by bitrate and reliability. The reasoning capacity metric captures the convergence of computing and communication, reaching beyond Shannon's limit. Semantic impact quantifies the gain in time and resources when relying on representations versus raw data. Chapter 10. Digital Twins in 6G. Learn how the network maintains perfect synchronization through distributed computing. The 6G digital twin is a dynamic, real-time reflection that allows us to simulate and optimize human society. Welcome to the intelligence era. Welcome to the era of the digital twin. Join us as we explore the future. 6G transforms data into understanding. Stay connected, stay smart. Farewell. Thank you for joining this 6G technical masterclass. The mirror world is synchronized. Knowledge is power. Thank you for joining this masterclass. The future is no longer just fast, it's smart. Stay connected to 6G. A semantic language is fundamentally different from a natural one. While words are the atomic unit of natural language, a representation is the unit of semantic exchange. Kolmogorov complexity measures the shortest binary description, enabling the apprentice to autonomously generate semantic content elements. We must separate the data into learnable parts, the core of semantic information, and memorizable parts governed by pure randomness. Reasoning only over learnable data points leads to meaningful models, avoiding the spurious representations that plague traditional data-driven AI. The independent causal mechanisms principle ensures that distinct semantic content elements can be easily separated from one another. Interventions on the causality ladder rank higher than associations, allowing us to build representations that don't just rely on observation. The application intent layer is responsible for intent mining, deconstructing user requests into actionable network policies. By sandwiching the reasoning plane between control and user functions, we feed the network with information for real-time synchronization. The communication symmetry index characterizes the reasoning state from a low-knowledge apprentice to a mature semantic equilibrium. Equilibrium is reached when the teacher and apprentice majorly rely on semantic transmissions, minimizing raw data exchange. In non-terrestrial networks, semantic showers offload the language foundations to receivers, overcoming intermittent satellite links. LEO satellites deliver global coverage for city-scale digital twins, relying on the robustness of reasoning-driven synchronization. While traditional capacity is limited by Shannon's bound, reasoning capacity is bounded only by computing resources. Causal representation learning equips the network with a rationale beyond simple statistical association between variables. The network protocol layer parses and forms semantic protocols, optimizing existing network functions for application intents. Finally, the physical bearing layer converts these semantic representations into physical signals suitable for 6G transmission. In Industry 5.0, digital twins enable high-precision manufacturing through zero-latency virtual feedback loops. Ubiquitous 6G infrastructure forms the nervous system of the smart city, maintaining real-time global synchronization. The result is a global mirror world at an unprecedented scale, where data understanding drives human progress. We are witnessing the end of the bit pipe era and the dawn of network intelligence. The 6G semantic revolution is here. Welcome to the intelligence era. Welcome to the era of the digital twin. Thank you for joining us. Knowledge is power. This is 6G. Stay connected. Digital twins for 6G. The semantic revolution. A technical masterclass. Holographic teleportation requires a disruptive leap in network architecture to support 2.0 Tbps data rates. The data tsunami is not just a bandwidth problem, it's a structural challenge requiring contextual understanding. We escape the Shannon trap by moving from reconstruction to reasoning, relying on computational semantic yield. In the teacher-apprentice model, the receiver generates its own conclusions, reducing reliance on the wireless channel. The hierarchy of meaning breakdown allows the network to deduce intent even if some symbols are lost. AI-native systems exploit cumulative knowledge to perform operations that bit pipes simply cannot execute. Mathematical do operators allow machines to perform what-if analysis, building a common semantic language. Intelligent semantic information flows deconstruct the stack, replacing bit-to-symbol mappers with meaning. Semantic-based KPIs characterize the impact a representation generates, moving from uncertainty to understanding. City-scale digital twins evolve with every interaction, creating a dynamic reflection of human society. Welcome to the 6G semantic revolution. The future is smart. Welcome to the era of the digital twin. Masterclass complete. Thank you for your time. Stay tuned for more 6G technical insights. A semantic language is fundamentally different from a natural one. While natural languages rely on deterministic syntax, a semantic language is built on the causal and statistical properties of data. We move from a bit-agnostic representation to one where bits are aware of meaning and context. Semantic representations must satisfy three key properties: minimalism, generalizability, and efficiency. Minimalism characterizes structure with the least elements possible. Information is no longer just uncertainty. It is semantic substance. A data stream is rich in semantic information if it improves reasoning. Successfully representing structure depends on contextual knowledge and the capability to reason over minimal representations. This is the pedagogic process of semantic didactics. Chapter 6. Reasoning-driven networks. 6G is AI native, moved from training-dependent decisions to proactive reasoning. These networks exploit causality and stochasticity. We are transforming transceivers into teachers and apprentices. The transmitter is a teacher capable of disentangling semantic content elements. The receiver is an apprentice that understands minimal representations. This allows radio nodes to acquire human-like reasoning faculties. Reasoning capacity is no longer limited by Shannon's bound, but is bounded by the convergence of computing and communication. Chapter 7. Causal reasoning and the ladder of causality. We examine 3 levels: associations, interventions, and counterfactuals. Causal identification identifies the root causes, while statistical inference attributes a minimal representation to that causal model. Interventions ranking higher than associations enable the construction of representations that do not rely on the observed data stream. Causal representation learning can be leveraged to establish a strong semantic connectivity between teacher and apprentice. Chapter 8. The IESC architecture. This revolution requires a rethink of the wireless protocol stack into 3 semantic-empowered layers. The reasoning plane acts as a master to guide user and control functions, performing synchronization and integration of knowledge. The introduction of this plane will modify RIC functions in ORAN, making operation more intent-based and automated. This architecture ensures that 6G is a complete re-engineering of the physical and networking layers to act as a language medium. Chapter 9. Semantic-based KPIs. The Communication Symmetry Index characterizes the reasoning state between teacher and apprentice. Semantic impact quantifies the gain in time and resources when relying on representations versus raw data. Performance in 6G is no longer measured solely by bitrate. We move from uncertainty to a metric of understanding. We ensure network efficiency and sustainability through the fusion of computing and communication resources. Chapter 10. Digital twins in 6G. From smart city management to high-precision industrial twins, 6G maintains perfect synchronization. We use semantic showers to offload information to apprentices who then generate service content locally. The 6G digital twin becomes a living replica that evolves with every interaction, simulating the future of society. This is the end of the bitpipe era and the birth of native network intelligence. Welcome to the intelligence era. We are moving toward immersive communication, holographic teleportation, and the birth of the global mirror world. Our current bitpipe models are reaching their breaking point as the volume of bits becomes unmanageable. By exploiting accumulated knowledge, the network can reduce reliance on brittle spectral resources. The transmitter explains meaning to the apprentice, moving from bit reproduction to knowledge exchange. The hierarchy of meaning allows the network to deduce intent, even if symbols are lost during transmission. These networks exploit causality and stochasticity to deduce connections in real time, building a sustainable intelligence. We examine Pearl's ladder of causation, exploring associations, interventions, and counterfactuals for 6G logic. The reasoning plane coordinates every layer to serve specific application goals through intelligent information flows. Symmetrical communication paradigms allow for real-time prediction and agility needed for beyond 6G systems. City-scale wireframes with glowing pulses represent the global knowledge base in action. Causal inference enables the receiver to predict states instead of just reconstructing symbols from bits. Every entity is a living part of an interconnected global knowledge base, synchronizing our physical world. 6G transforms data into understanding. This is the future of knowledge. Farewell. Chapter 1. The 6G Vision. Beyond 5G, we are entering an era where physical and digital boundaries dissolve. Chapter 2. The Data Tsunami. 5G was built for data, but 6G must handle the exponential explosion of twins. Transmitting every single bit for real-time virtualization is becoming mathematically impossible. We hit the wall. Instead of bits, we transmit meaning. Semcom identifies the core structure, doing more with less. We break the problem into levels: technical symbol accuracy, semantic precision, and pragmatic effectiveness. 6G moved from bitpipes to teachers and apprentices. We are building a native network intelligence. The mathematical do operator allows machines to perform what-if analysis, establishing semantic logic. We deconstruct the stack into intent, network, and physical layers, coordinated by the reasoning plane. We establish new metrics, symmetry index, semantic impact, and reasoning capacity to measure 6G performance. The 6G digital twin is a real-time reflection, creating a living replica of our society globally. 6G transforms data into understanding. Welcome to the intelligence era. This is the 6G revolution. Stay connected to the future. Stay smart. Knowledge is power. Welcome to the era of the digital twin. 6G satellite constellations provide ubiquitous connectivity, ensuring the mirror world reaches every corner. Chapter 2. The Data Tsunami. We are drowning in data, but starving for knowledge in the current bit pipe era. We are hitting the Shannon trap. We need a paradigm shift from pure reconstruction to contextual understanding.